Don't you watch when you're going, you old goat?
I'm sorry, Uncle Darko. I tripped over you. Oh, Uncle Darko. Oh, I'm gonna fall.
I don't give a shit.
Good morning. Good Monday morning to you all. It's 10:35 right now in the morning. Got two packages here, and I'm not quite sure what they are, but I'm hoping it's the Amphenol 8-pin plug and the 10 microfarad fan capacitor. We're going to find out. I'm going to open these right now, and if it is, we can run a test on it. Now, one of the things I had mentioned before I wire it up into the male plug that's going to go into the socket where the ballast was, I want to put clip leads on it, and I want to use the capacitor and the CL90 in series, and I want to see what the filament string has for voltage at that point. Once I establish that, then I will wire it in. And like all my videos, I do not record my actual wiring because I've got a lot of problems, you know, and it takes so long for me to see what I'm doing that I usually show you afterwards, you know, when it's all done. I also got the tube tester back in the case. It looks pretty good. As a matter of fact, this camera's tripod is sitting on top of the tube tester case right now. The top cover's all done. Everything's all in there. The tube tester's all in and screwed down, and I put a tube in it to make sure that it's still working good. And she's all set. So now, let's get on to the opening these here. We can't really say unboxing, if you can call that unboxing. So, I guess the first thing we're going to open, we'll move this box out of the way, we're going to open this one here. And, okay, this is the fan capacitor. Now that's big. I might not be able to mount that on the socket. That's good size. Well, you know what I'm going to do? I'm going to put this on that Chinese capacitor checker that I got. That blue job I showed you. This is 10 microfarad. I'm just curious to see what that'll read. Okay. You know, I could wire that under the chassis and put only the CL90 on the plug. Before we do that, let's move this out of the way, and we're in here. Okay, I just want to make sure. Look at the paperwork after on that. We want to make sure that we are in camera. Oh, I hate these things. It's got all 8 pins, which is good, because you know, I don't have any tubes. I'm still recording in camera view, that is, too. I don't have any tubes that I can sacrifice to break a base off. I mean, when I had my old shop, I had junk tubes around, and you know, you can always use the base of them. But this here is good as long the pins just look like they're closer together. I hope it's a standard. It's an 8-pin socket. The guy told me, I emailed him, you know, on through the auction, I should say, and he says yes, it's a standard socket that'll fit a 6S and 7. I use that as a reference. So I guess the only way to really try it would be to put this into the ballast socket, is to put the CL90 in series with this capacitor. But all this is going to be done on clip leads under the chassis for now. I'll pull the ballast out, see what my voltages are, and then go from there. When this gets up to full heat, when it's in series with this, it should only be a few ohms. So what I'm going to do is I'm going to be putting a voltmeter across the CL90 or the S-82, they're both basically the same, and see what the voltage drop is across it. As far as the capacitor, I don't really probably need to put a voltmeter across the capacitor to see what the reading would be. I think that my main concern is that the 6.3 volt tubes that are in that radio and the 25 volt tubes, there's two of them, a 25L6 and a 25Z6. They make sure that they are getting their 25 volts and 6.3 volts respectively, and that's my concern. And this controls the surge, so it's a soft start. So enough flapping. The first thing I want to do is to see if this will fit into the socket, because to me the pins look like they're really close together. All right, I'm going to take out the ballast very gently. Not easy to get out because there's not much to grab. To see what I mean? I bent it already. I always had that, never had problems getting that ballast out before. That's what I mean. It's going to get broken, and this is why it's not covered. You break that nichrome wire off of there, you might as well throw it out, but you can't solder that. Let's try this plug. Because if it don't fit in here, then I got to put the CL90 under the chassis. Oh, it's too loose. It goes in. Well, okay, it does fit. It's my eyesight. Okay, good. And it's got a nice wide, it's almost a ½ inch high, nice wide rim, you know, in other words, it's tall, and I can get my fingers on it, unlike the ballast. Oh, good. See, it fits in. He's got to push it down. So we can't put this up there. It looks, not only looks ridiculous, it's too damn big, and there'd be no room for the CL90. It's hard to tell when you buy something online. You know, they look small. Sometimes things look big. Picture's very deceiving, but that's not a problem. I can mount that. It's even got a little place to mount it on the chassis. The wires are long enough. I could probably mount it underneath, off to the side. But I wanted to be able to do it so that I can pull it out, but that's not a problem. These things aren't going to run hot. They might run lukewarm, if even that. So the CL90 will sit on this, and a resistor if needed. So enough of this. Let's go run a check on this now with the voltages. All right. Got my little capacitor checker, which is quite accurate. All right, and we're going to test this capacitor here. This is what I'm going to be doing, so just watch the meter. What I want to do, you know, this is red and black. Makes you think that it's a polarized capacitor, doesn't it? But look at it. It's 250 volts AC, 50-60 cycles. So I'm not sure what scale I'm going to be reading on here. Let's see. We're not getting anything there. Let's go to the next one. 9. All right. 10 microfarads. 10 microfarads right there. On the 200 microfarad scale. Okay, so that we know we're right, just about right on the money here. All right, just for the heck of it, we'll put it on the telemic, and we'll see what we got. While the telemic is warming up, it won't really take that long. I got these stick-on feet, and I got 4 of them on the tube tester. And I figure, you know, these should be good enough. I don't have anything else I can use. It's not really vintage. The tube tester's over here, and it's got the 4 feet on it. And my setup charts are inside, and the tester's all screwed back down in there, and everything's working good. So you can see that the hinges, Buzz, look pretty good blended in there, don't they? But, you know, if you look over on this side here, the latches aren't painted, you know. Now, if you owned this tester, you'd probably paint these latches red. And these hinges over here, you'd probably paint them red, too. You know? You know, there's a saying an old guy used to say. A real old guy. He was well in his 80s when I met him 30 years ago. He was not a radio man. His name was Bill Bishop. And he would say, boy, this guy here, he sure is a pistol. Is that what you are, Buzz? A pistol? Okay, enough kidding around there. It's all in good fun. All right, now let's get my magnifying glass here because I can't see. I'm blind as a bat, as you well know. All right, so we're going on 10 microfarads here, so we want to go on to the scale here. All right, and we're on the C4 scale, which is right here. So let's tune that. Let's just watch the eye. And we've got to do a little fine tuning, so we got to grab it like this. All right, let's see. There's your 10 right there. See it? I'll move it off so you can see it. See the 001? We'll look above that. There's a 0.1 and then there's a 10. We're right on 10. And I don't know if power factor works on this or not. Yeah, it does. All right, power factor's all down low. You see, and you try to turn it up, you get a smaller eye. So the capacitor is excellent. And we're not going to run a voltage check on it. It's good for 250 volts AC. So we're only going to be using it for that, so I'm sure we don't need to run a voltage check. Now, generally speaking, at least from way I understood it, and I could be wrong, because I've been wrong before. In matter of fact, I'm wrong more than I am right. Generally speaking, and please correct me if I'm wrong, 250 volt AC capacitor is usually about 500 volts DC. So in other words, it's usually double. Or in that ballpark. So in other words, if I put 500 volt DC on this, that would be the maximum I could put on it. But we're only running 117 to 120 volts thereabouts on this capacitor anyways. All right, enough of that. Let's put that down. Let's shut that off. And remove the capacitor, and let's get started on this radio here. I don't want to bore you too much with my flapping. I broke the damn keyway out of the ballast. I just noticed this. I found this on the bench. I broke the damn keyway out of the ballast. I'm like a bull in the china shop, you know. If it ain't one thing, it's another. All right, I got a Mickey Mouse set up here, wires. This is how I used to do things years ago. And, oh, it's hard getting in here and working. I can only tack solder it. I cannot even begin to do anything better than that. So, right at this stage of the game, I'm going to be putting the voltmeter across this and see what the voltages are. Then I'm going to shut the radio down, and then I'm going to check, put the voltmeter across one of the tubes. That's all I need to do is put the voltmeter across one of the 6.3 volt tubes, and then relocate the leads to one of the 25 volt tubes and see what the voltages are with this in there. But I need to see what this will start out with as a voltage drop first, and then go from there. Now, if this thing reduces the voltage too much after it's fully heated up, then I'll have to eliminate it. But we won't know this. We won't know any of this until we get started on this. Now, all right, I got the meter on AC volts. I got it across the thermistor. I got the radio isolation transformer on now, and all I got to do is turn the power switch on the radio and just make sure nothing is shorted. And I'm going to be monitoring the tubes here. Right now I'm going to turn it on. I'll have to play this video back to see what the surge was. Thermistor is warm. The voltage drop across the thermistor is dropping. But still quite a few volts drop across it, but we'll give it a chance. We still have to measure the filament voltage, because the capacitor might be giving me more voltage on the tube filaments, in which case this drop would be okay. Well, about 10.2 volts right now. Now that's the main thing is what the voltage is going to be when it's fully warmed up, and that's what it's got to be now is fully warmed up, I would think. This thermistor is pretty warm. You can't keep your hand on it. Down to 9.3 volts, and the tubes are lit up normally. Capacitor's running cold. Now, I'm going to leave this meter in this place, and I'm going to shut everything down and relocate my meter leads, leaving everything else hooked here. I just got to take the meter off the thermistor and connect them to one of the 6 volt tubes and one of the 25 volt tubes, and I have to keep shutting the radio down because with my bad eyesight, things slip very easily. I short things out, you know, so I have to shut the radio down and bring it up again, and you know, each one of these tests that I do. Okay, so what do we got here now? We got 7.15 volts. Okay, so let's see what the thermistor is. Thermistor's pretty hot. You can't keep your finger on it. All right, so the voltage drop across the thermistor is 7.3 volts, okay? I don't think it's going to be any different. Now, of course, the filament transformer is in the circuit too. I'm going to check the capacitor. Capacitor's ice cold. So there's no problem there. The problem is going to be trying to get this big, huge capacitor under the chassis. All right, power's going on now. I'm across the 25Z6 rectifier tube, so it's the 25 volt tube. I was getting about 20 or 21 volts before. So I'm going to leave it on for a minute or two and see what it is. Radio's on. The filament's climbing very slowly. You should be able to see that, but if you don't, occasionally I'll read off the readings to you as I see them. Up to 19 volts now, 19.9 up to 20. If I don't get enough voltage on this, I may eliminate the CL90. We need a soft start, but you know, the capacitor alone might give me that. I don't know. I can certainly find out. The CL90 is getting warm. I need 21 volts though. That's still not enough volts for a 25 volt rectifier tube. That's the whole idea of getting rid of the ballast, because it's not giving me enough filament voltage when the radio is fully warmed up. And I'm not talking about the surge now. We don't want a surge. We're not getting enough voltage on that 25Z6. See if this camera's still recording. Yep, the light's still blinking. All right, so you saw how long it took for the CL90 to go down in resistance. The CL90 or the S-22, as a matter of fact, I got the S-22 in here. That's what's on the clip leads right now. It takes quite a while for it to drop down to just a few ohms, but maybe those few ohms is too much. But you know, 21.3 volts, that's not enough. If that was up to around 23 or 24, I would probably say yeah. Now, because of, like I say, my eyesight, if I stop moving clip leads and go to another tube, I'll probably cause a problem here because the wires are too close together. While that's sitting here, you can see it's just not going to go much over 21 volts, 21 point something. Okay, I shut the radio down, but only for a brief time, just so I wouldn't zap anything. I'm across the 6SK7. That's not enough voltage. I'm sorry, guys. I'm sorry. But this thing's... You gotta have 6.3 on the damn filaments. If you're running tubes... Unless the tubes are... The tubes that are in here are new old stock. Thanks to one of my... matter of fact, Radio Wild. I appreciate the tubes. He sent me a set of tubes for this radio. Now... Those tubes probably will not cause any problem running low on filament voltage. But as tubes age, if you're not supplying enough filament voltage, you know, your radio isn't going to be very sensitive. It's just not going to play right. 5.6 volts. It's just not enough. So, what I'm going to briefly do right now, Remember, it's my idea to put a CL90 or a S-22 in series with the capacitor. That was my idea. I hope you can still see that. I'm getting an awful lot of reflection in this. Okay, I think I got it now. I'm going to momentarily short out the thermistor. Let's see what the voltage is. Matter of fact, let's use a clip lead. Take a clip lead and put it across there. Make a better connection. So we're going to take a clip lead and go across the thermistor. Alright, here we go. Okay, the thermistor is now shorted out. .9 volts. I can live with that. The capacitor is all you really need. We don't need the thermistor. Brendan said, yeah, the thermistor, putting it in there will give a soft start on the B+. But this radio, as I recall, does not have very high B+ voltage. The electrolytics that are in here are 160 volts that I replaced, you know. And as I recall, there isn't very much voltage on this radio. I could be wrong. I could measure the B+. Wouldn't take me very long to do that. I'd have to shut it down so I don't zap anything with my clumsiness because of my rotten eyesight. But I don't think there's any problem with a surge. What I'm going to do, I'm going to put the meter back on the 25 Z6. And I'm going to shut the radio down, of course, when I do that. I'm going to leave out the thermistor and see what the surge is across that tube. But I don't think we need a thermistor. You can see that we're 5.98. That's across just one 6.3 volt tube, and they're all going to be about the same. So we're still not getting 6 volts on the filaments. There's no other ballast, resistor, or anything else. What we're doing now is running directly through the 10 microfarad capacitor, which right at this time is running cold. Alright, let me stop the recording. I'm going to relocate the test leads back over to the 25 Z6. We're right back. Alright, I got the test leads across the 25 Z6. But the radio's only been off for about a minute. So the tube filaments are still warm even though they're off. So we really can't tell the exact surge. I'm going to have to play this video back to see what the surge is, because I want to take a visual look at the actual tube, and I can't look at two things at once. So let me just see if we can get this damn glare out of here. Alright, I think we got the glare out. So I'm going to have to rely on the video for the surge as far as voltage is concerned. And I'm going to do a visual inspection, and I'm going to turn the radio on right now. I got the power switch off, the isolation transformer's on. So I'm going to be looking at the 25 Z6. No, she comes up really slow. No surge or anything. Now, again, I want to mention that the thermistor is still shorted out. It is not in the circuit any longer. So, in reality, I put that capacitor under the chassis. I won't even need to use that plug. I'll just leave it in the ballast socket for future use. Otherwise, it'll get lost. We're getting 22.4 volts on the tube. Now, what I'm going to do now is I'm going to shut the radio off. I'm going to shut the camera down, and I'm going to come back on this in a half an hour. And at that time, we'll make the final test with actual cold tubes, where the filament had a chance to cool right down. We'll come back. For you, it's only going to be a few seconds. For me, it's going to be about a half hour. What a mess, huh? I got the filaments pin 2 and 7 on the 6-volt tube here. The 25 Z6 filament pins are mounted here. This will be the 25 Z6. This will be the, I think it's a 6SA7. But anyways, we're going to monitor the surge. It's been over an hour. So we're going to get the camera set up. Make sure that I can see both of these screens on the meters without having a glare. And we'll see what the surge is. Running directly, using only this capacitor. The CL90 is out of the circuit. Okay, we got both meters on. We're going to fire up the radio. Here goes. No surge there. Now, I'm using a different tube for the test. That's why it's a little different voltage here. And because our line voltage might have climbed a little bit too, so. But you can see it settles out at about 6 volts. I can live with that. No surge at all, no flare-ups or nothing. So, that's what we got. We're 22.8. I can live with that. 6 volts on the 6SK7. I'm not sure if there's more than one 6SK7 in here. I got to look at the schematic. Yeah, there's 2 of them. Okay, so I'm monitoring one. So the other 6-volt tubes are going to be about the same, within a fraction of a volt thereabouts. Okay. Well, 5.9 volts, you can see it dropped. 22.7 here. Alright, this is how I did it. What a hell of a job soldering, getting the wires to stay in this socket. Because I can't see what I'm doing. So I think I got it in, I went to plug it in and the wires popped out. So I put so damn much solder on it I made the pins fatter and then thinned it out by hitting it with the soldering iron. I just poured the solder in the damn thing until it took. So this is how I had to do it because I can't get, there's not enough room under the chassis. If I was to mount this under the chassis, it would block the tube sockets if I had to get at anything. So there was a hole here on the chassis where there was a little rivet where the old electrolytic was. I drilled that out and put a 440 nut and bolt in there, and now we're all ready to fire it up. It's not really the way I wanted to do it, but it looks okay. In other words, you'd have to, if you wanted to replace this, would have to take out this screw here and unplug this. So we're going to put the radio on right now, and I got the volume turned up, but there's nothing on the antenna here. It's a very slow start. You can see the tube glowing. You may not be able to see it with the shop light on. This is the 25Z6. Sounds good, I mean. Okay, so you saw the voltage readings. Next step I gotta do is I gotta file the sandy ends of these bulbs, get the circle is spread out a little more, especially on this one because this is too close. I have to make some kind of a bracket and actually have to drill in the old one, which is broken off, and try to get this back more, but maybe this is hardly, just barely lukewarm, so I don't have to worry about it. It's about 3/4 of an inch away from the dial anyways. I could probably file that. I can do that off camera. Okay, so I did want to show you that, and as you can see now the tube is lit up properly. Capacitor's cold, and that's it. And there's a little jumper I put in there. It was real difficult getting that jumper in there and this wire, but I got it in. But boy, what an aggravating job, because I just can't see what I'm doing. But it's in there, and other than the dial lights, the radio's done. Well, I don't think filing off the bulb does all that much. This is 220 paper. This is the paper I used on the tube tester cabinet. You can see it leaves a dark circle in the middle, and I went flat across the whole thing, and then I even spreaded it out a little bit. I didn't do anything with this, but this one's further away, so there's a dark area here compared to the outer rim. But this is much darker. It still don't cover the distance, and I'm going to have to pull this back. I don't think filing the tips of these things does much of anything. It did bring it out just a little bit, but not much. So it's not worth ruining the rest of my bulbs doing it. I just did it on this one, and I could probably take it out here. Hang on a minute. But you can see I just went around it. Now I'll try to flatten out. Maybe I need to flatten it more. I don't want to take too much off, or it'll get right down into the LED. But I'll do that and come back on this in a minute here. Well, didn't really do that much. It's still got that dark area in the middle, but let's take a look at the dial on the front. Now, it did bring it out a little, but if I wanted to read down at the broadcast band down here, it's kind of dark. I didn't do anything with the band spread at all. You can see how bright this pilot light is here. It's really bright because I had to put a 47 in here. I wanted to put a 57, but it wouldn't fit in there physically. Anyways, now, the bulb is flat on the end right now. It's very flat. So it'll probably be all right. I'll have to live with it, I guess. I could probably change out these sockets and put in 2 or 3 of these bulbs in here. I want to get this whole dial lit completely, not just here. I want this whole thing evenly lit so I can see which end I'm going at. You know, I want to see the dial. I want to see the entire dial. But that's for another video, if there is going to be one.